Professor Urmi Shah from IT/ICT Department of LG Institute of Engineering and Technology. In the previous session, we have discussed the basic introduction to communication system. What is communication system? What are its elements? And the need of modulation is discussed. So in this session, we are going to cover following topics. That is classification of communication system, signal representation and its analysis, and applications of communication system. So the first point is classification of communication system. Basically, how the communication system is classified, on which parameters, that we are going to see in this session. So the first point is based on the nature of independent variables such as time. So based on this parameter, it is classified in two types, that is continuation time signal and discrete time signal based on the nature of independent variable. The second classification is based on the nature of dependent variable, that is analog signal and digital signal. The third classification is based on the nature or the number of independent variable, that is one-dimensional, two-dimensional and multi-dimensional signal. So this is the basic classification of communication system. The further classification of communication system is based on the periodicity of the signal. How the signal is periodic or not, that is the classification based on periodic signal and aperiodic signal. The further classification is based on the nature of indeterminacy, that is deterministic signal and random signal. The further classification is based on causality, whether the signal is causal, non-causal or anti-causal. And the final classification is based on the energy content of signal, that is energy signal, power signal and neither energy nor power signal. So this is the classification of communication system. Now what are these signals that we are going to see? The first is the continuous and discrete signal. This signal is continuous with respect to time, that is the continuous signal. And discrete signal is having some discrete points at specific time interval. You can have some specific amplitude. So these are known as discrete signal. The next example is analog and digital signal. In this signal, analog signal is continuous. It will be repeating for certain instant of time with same amplitude. While for digital signal, this signal is represented in form of high or low logic. Whether it can be high or it can be low logic. So this is a digital signal. An analog signal is in form of continuous sinusoidal form, that is it will be having continuous flow for specific instant of time. Now the next is based on dimension. The signal which are based on dimension are classified as one-dimensional, two-dimensional and multi-dimensional signals. A function of independent variable such as time, distance and position. These signals are classified based on some function like time, distance and position. For example, you can have the basic example of one-dimensional signal, that is the speed signal or audio signal, or your music system, ECG system or time series system. So these are all one-dimensional signal. Two-dimensional signal can be the image form. The image form on your desktop, on your mobile phones, those images are in form of two dimension. So this is the example of two-dimensional signal. Multi-dimensional signal is what you all might be watching right now. That is video signal. You can have speech, you can have image, both combination you can have, that is a multi-dimensional signal. So this is the classification of signal based on dimension. The next type of signal is the periodic and aperiodic signal. Periodic signals are going to repeat after a certain instance of time, while aperiodic signal won't be repeating after a certain time. Their nature will be aperiodic for the whole instant of time. There won't be some specific repetition of signal amplitude for this aperiodic signal. While in the periodic signal, you all can see the repetition of cycle takes place for the periodic signal. So this is the example based on the periodicity of signal. Now the next type of signal is the deterministic and random signal. Deterministic signals are repeated or represented in form of mathematical equation or some lookup table. If you have certain formulation or mathematical equation of signal, then that signal is known as deterministic signal. Random signal don't have any mathematical equation or lookup table form. They can be random in terms of any parameter. So those are random signals. Deterministic signals are preferable because whenever we are doing any mathematical analysis or processing of signal, then this deterministic model is used. While random signal is not preferable as they cannot be described with the help of some statistical models. The third point of difference is deterministic signal can be evaluated in terms of time, that is past, present and future prediction of variables can be done in deterministic signal while it cannot be done in random signal as they are random with respect to time. So the value of random signal cannot be evaluated at any instant of time. The basic example of deterministic signal is sine or exponential waveform, and the another example of random signal is noise signal and speed signal. So this is the basic example or basic classification of signals in form of indeterminacy. The next classification is in terms of causality. What is a causal signal? Basically, causal signal will be zero for all negative values of time. For rest of the variables of time, it will be having some integer value. But for all negative values of time, causal signal will have zero value. What is anti-causal? The exactly opposite of causal. It will be having zero value for all positive values of time, and it will have some integer value for all negative values of time. This you can see by the waveform described here. And what is non-causal? Non-causal signal will have integer value for all values of time signal. So this is the description or the waveform analysis of causal, anti-causal and non-causal signal. The next classification which we have here is the energy and power signal. A signal is called an energy signal when it has some finite amount of energy. The formulation for energy is integration from minus infinity to plus infinity if the signal is x of t, then x square of t dt. So this is the formulation for energy of signal. For finding the power of signal, the formulation is limit t tends to infinity where t is your time duration 1 upon 2t integration minus t to plus t x square of t dt where x of t is your signal. Basically, a signal is said to be power signal when it has some finite amount of power. So these are the description of energy and power signal. So we have seen the classification of communication system. The basic examples of communication systems are here. Internet, public switch telephone network, intranet, ethernet, television. All these examples you have seen in your real life applications. So these are the applications of communication system. The next applications of communication system are TV broadcasting, FM and AM broadcasting, cable TV, fax machine, pagers, navigation, telemetry, radar, surveillance, that is your military applications, then sonar. So all these are the applications of communication system which we are using in our day-to-day life. And your LAN, that is local area network, telephones, all these applications we have seen in our day-to-day life which are said to be examples of communication system. The reference books for these topics have been listed over here. You can refer any of these books for this topic. So we have discussed today what is the communication system and what are its different classification, how the signals are classified in terms of communication, what are its basic applications and examples, where it is used in real life. So all this we have studied it in this session. Thank you very much for watching this session. In the upcoming session, we will be discussing with the next module that is related to noise or interference signal. Thank you for watching this session.